Hey everyone, AMR back again with another Python tutorial. So in this one, we're going to be covering the decorators, the type hinting, and the subprocesses. So in my last video, which I'll have a link to it right here, I actually had covered a few of the more basic concepts. I'm not going to cover them again, so please give that a watch if you have missed the first one. But I think this is going to build off, and the biggest goal here is to be, by the end of this whole entire process, that you have a understanding of how Python should be implemented and used, and you could actually have a full-fledged application that's hosted somewhere with best practices being followed inside of the Python community. So I'm actually going to sit down right now and try and knock out probably like 5 or 6 of these recordings. I will be honest with you, I have planned probably close to 20-25 recordings in total of these Python things, where I'm covering 2 to 3 topics at a minimum for every single video. Python is a huge, huge, huge programming language, and this is just kind of like a jump-starting course to understanding like basic concepts of how to use Python and the beauty behind it. I don't think I'm going to cover like data structures and algorithms and all that kind of stuff. I don't think that that's really useful in this case because that is language independent. Those are more of a, I don't know how to say this. Those are more of like a comp science type of a video, which I could definitely do if I get enough feedback saying that that's what you want. I do have a degree in computer science, and I don't know. It's up to you guys whether or not you want to have that video. I'll leave it open-ended, but as always, if you like today's content, feel free to like, comment, and subscribe. It helps out the channel a ton. But let's go ahead and get into some of the questions here. So for our first question, we have, what is a decorator? As always, I will have the questions and the answers in the description down below in the video, so you can like go ahead and pause the video if you want now, or you can just look at the answers down below. But let's go ahead and jump into it. So what is a decorator? So a decorator is essentially, I'll go ahead and talk about it and then I'll go ahead and type it out for you guys. But essentially what a decorator is it's a function that takes in another function and returns yet another function. That is, in short, what a decorator is. It can be super useful because, like, I'll cover that down here like a little bit later as you see the third question. But at a base level understanding, it is a way to have like an inner function defined where all you have to do is annotate it with the @ sign and then the name of the function that you want to be encapsulated in this function that you're trying to declare. So next question here we have, when should I use a decorator? This is a very common question, and I really wish that people would ask this more. There's a lot of work that's being done in the Python community that could be achieved through a simple like decorator type class or decorator type method. And so I've typically in the past, what I've done when I create like these Flask APIs and stuff, I do a lot of the security for like lower level applications, one that's not necessarily going to like be a huge burden, especially if it has like a Go proxy around it or something similar. I'll write some type of a decorator that is going to be on the outside of the function. So that way, when a request comes into the function that I'm trying to achieve, the decorator gets called first. It does some type of authentication and then either returns back a, yep, this is okay, you can go ahead and proceed into the function, or it immediately rejects them and sends back a generic 401 JSONified response. So in short, I think that decorators are super useful whenever you want to reuse code across multiple platforms without having to redo a bunch of work for a specific goal that you're trying to set. So it's all about like saving work later and being able to reuse code for many different use cases rather than just try and write a particular function that's only going to solve a singular use case per time. And then, so this brings us to our last question here, where it says, why are decorators useful? So I kind of touched on it a little bit in the first one, but decorators are super useful because they allow us to write a code once and use it everywhere. You don't really get that functionality with pretty much anything else that you do. And, you know, it's kind of like a way to write something and then have it extend off of an existing function. And then you don't have to change or modify the existing function's code in order to account for the decorator that you're trying to implement. So it's all about like making your life easy. I think that they're mostly useful though, when you have a particular objective that you're trying to achieve, and it could, you know, have many different use cases that come through. Like, for instance, if you want to add two things together and then you want to be able to change up the input types between integers and a list of tuples, and like the list goes on and on, honestly. But decorators are super useful because they allow us to do so much in such a small amount of code. And honestly, I think that the Python community needs to try and be more strict on like getting people onboarded with the whole concept of what a decorator is. I don't think it's really utilized as much as what it should be. This thing is super powerful, but yet it is widely overlooked by a lot of people. So down here we have an example function. So I basically just said, let's consider that we have a function named sum function below. It takes in two values and it returns the difference. So as a starter block for this example file, I'm going to go ahead and try and go off of my third example's answer and try and give you some type of an example output in Python. So down below we have that function defined where it's taking in what we're perceiving as probably a float or an integer object, or data type, and it's going to go ahead and return the difference of the two. So what I would like to do through the use of a decorator is to be able to pass in a list of tuples and still get the same type of functionality through use of decorators. So let's go ahead and see what that looks like. Okay, so I went ahead and created a decorator type of my decorator. Okay, so essentially what it's going to do is it's going to have a nested function on the inside called inner that is going to have tuples as a value being passed into it. And then it's going to return the original function being passed in. In our case, it'll be sum function. And every single time that it loops over that list comprehension seen on line 27, it will send those pairings from the tuples into the func call, which is sum function in this case. So value subscript 0 will be X and value subscript 1 will be Y. And then every single time you will get a new value tuple populated in that list comprehension, which is the difference between 0 and 1 in the tuples. So for instance, if we were to pass in a list of tuples of 1, 2, 3, 1, 10, 6, and then what we would do is we would say output equals, and then I would say sum function, and I would pass in, I believe that I'd pass in this. So let's go ahead and set this equal to input. We can't say input because that's a declared function inside of Python's built-in library. Let's just go ahead and, what should we say? Let's just say data. So we have data there. We're going to go ahead and pass in data. So what do you think, if you can go ahead and pause the video, what do you think output looks like? So output will actually be equal to, it'll be equal to a -1, 2, and 4. So if you got that right, congratulations, you kind of understand what a decorator is doing. For those of you that don't quite understand, that's totally fine, but I'll go ahead and go over it in detail here. So this first one in the list comprehension, so list comprehensions, in case you didn't know, is a way of taking a multi-line for loop and converting it into a single line of functionality and then populating the output every time that you iterate through the loop into a new element in the list. And so here we have function being called with the first parameters 1 and 2. So 1 will be populated here, 2 will be populated there, equating to 1 minus 2, which is -1, and then vice versa down the row. So 3 and 1 getting to 2, and then 10 and 6 getting to 4. So that is a decorator's use case at a high level. Let's go ahead and jump over into some type hinting and see where that goes. So jumping over here to type hinting, I have a couple of questions similar to like what I was doing with the decorators class, or the decorators functionality, I should say. And I pretty like defined this file so that way we could just kind of talk through some things. And then I'm going to give you some examples of how we use type hinting in Python. So for our first question here, we have, does type hinting prevent the application from starting? So honestly, it doesn't do a whole lot from a functionality perspective. It does a lot with like the way the program is being linted and how the IDE is going to interpret the incoming input. And then based on how you're writing code, it will try and say, okay, you've defined your type hint as an integer, but you're passing in a Boolean value. I'm going to go ahead and highlight it, but I'm not going to stop the programming language from actually compiling. Python is not a compiled language, so it's all runtime based. There's really no way for a type hint to stop the program from actually starting up since Python is runtime. But yeah, type hinting is super helpful. I'll cover that later, but for now, let's just go ahead and say that type hinting is not going to prevent the application from starting up. So for our next question here, let me go ahead and fix a typo really quick. So for our next question here, we have, why is type hinting important? So this is probably the most important question that I get asked all of the time when it comes to type hinting. So type hinting is super important because it instills best practices into software development and a programming language that makes programming so easy. So if you ever programmed in a compiled based language where you actually have to define what the data types of your variables are before you actually go ahead and use them. So this can be Python's way of meeting in the middle. So what I'm trying to get at here is that Python is giving you a lot of flexibility and not having to define what those data types are. So Python is giving you a lot of flexibility in that regard to like freely write code without having to worry about what data types are at the time of writing the actual physical code. You can actually just define it as some generic type and then Python will do the rest. So type hinting is a strong way to have people open up an application, open up a project on their machine, and then the IDE will like tell the developer, hey, you have this defined as a type hint of integer and you're passing in a Boolean value. This is a mismatch between data types and you might want to consider fixing this, or you might need to consider fixing your type hint. So it's just like a really nice way to allow developers to somewhat stay disciplined without having to have Big Brother looking over their shoulder. And like, I don't know. It's not required by any means, but I definitely think that if you go without doing type hinting, you're just opening the door for shooting yourself in the foot later. Type hinting is one of those things that it just makes an application feel more professional. And if you are able to continue practicing type hinting and stuff, it'll make transitioning from Python to Java or another defined data type language that much easier. If you get lazy with this stuff, it's going to be exponentially harder to get back in the habit of typing out your variable types. And then so for our last question in this file, we have, do larger tech companies require type hinting in their applications? So from my personal experience, there is really no like hard set standard as to whether or not Python developers have to do type hinting. However, it is strongly encouraged. I think that if you come into a programming interview with knowledge on what type hinting is and understanding how to type hint, I think that it actually speaks volumes to the interviewer that, hey, I'm actually pretty well versed in what these variables are. I know that I program in Python, but I'm not going to solely rely on Python's ability to interpret what type of values these variables are. I actually want to tell people that come into this application for the first time, this is what I'm expecting on the input and output. So I definitely think that tech companies are trying to encourage, like strongly encourage developers to have type hinting skills and implement it in their projects. But there really is no hard set standard that says, hey, this project is not going to be able to go into production if you don't have type hinting. I don't think that there's anything like that. Okay, so let's go ahead and jump down here to some examples. So first off, let's go ahead and talk about the actual package itself. And it is a built-in library it's actually a built-in module in Python's built-in library. So if you don't actually have to do any type of extra work in order to get this installed on your machine or anything. As long as you have a version of Python installed on your machine, you can go ahead and open up your shell and just type in import typing, and you should see it. So int is kind of a hazy type in type hinting. So what you'll find is that there are certain data types that you don't necessarily have to import from typing in order to get the desired effect. Int is one of those, bytes is another one, string is another one. We'll cover most of these here in the examples down below, but it is worth noting that there are a few where, if possible, if you can import it from typing, I think that that's actually best. But there are some built-in ones that I think that just take the cake. So int is actually going to be that first one. So if we have a function defined, all right, so I went ahead really quick before we went ahead and starting going through some of these typing. I wanted to go ahead and create an example function that we can just copy and paste down below into each one. I think it'll make for an easier transition to get your head around. I'm also going to be planning on having the this function pass in one data type and then returning another. So that way you can see the mismatch between the two. And honestly, it's just like a really cool thing to see. So for our first one here, I'm going to go ahead and copy this example, go down here into the int, go ahead and do a nice little paste. I'm going to say this is an int data type. So the way that we tell Python that this is a type hinting is through the use of a colon and then a data type. So there is definitely some magic behind the scenes. I'm not fully versed on how Python is interpreting this in the backend through like bytecode and stuff. However, I just know that the syntax for this is the colon. Colon is pretty useful in Python. So the colon dictates the key value pairing of dictionaries. It also dictates, you know, it can also dictate like ranges when you're talking about subscripting over an array or a list. And so for this case right here, the colon is actually syntactical. But in this case, the colon is actually indicative that you are trying to say, hey, the value on the left has a data structure or data type on the right. So we're being passed in an integer object there. And in the background, I think I want to go ahead and convert this to a string. So down here, I'm going to go ahead and change this up to strng. And so now we shouldn't see any problems, especially if I go ahead and erase our example. Now everything looks fine. The only thing that might be complaining is that I expected 2 blank lines. And so by that, I'd have to do something like this. And now it's a happy path. I'm going to go ahead and remove that now. So one thing to note is, like, let's go ahead and say that we just want to return eng. So we are expecting to return a string. And look what happens. Now eng is highlighted because expected type string got int. There's nothing to stop this function from actually running. I'll show you that right now, actually. So as you can see right here, you see that the eng is highlighted on line 29, indicating that you've defined this as a string value. However, eng is just being straight returned, and we've already defined the input as an integer. So we know that those mismatching in data types of the output. So let's go ahead and print out just 8 into it and see if this actually runs. As you can see down below, the program ran fine. Like I was talking about earlier, Python is a runtime-based language. There's nothing to stop the language from booting up. But let's go ahead and fix that back up now and return this back to a string eng, and everything goes back to a happy path. Again, the only reason that the squiggly lines are there is because of the blank lines. Go ahead and jump into our next example down below. So for this one, I'm just going to say example 1, so that way we don't have to keep on having to delete, and I can use these as a base. So float is actually going to be another one of those where you just pass in the actual float data, like built-in type in Python. And I want to go ahead and return this as a string as well. I think that that just makes sense. Again, highlighting the fact that if I just do eng, it's going to have eng be highlighted now, indicating that we've declared that the output be string, and it's just a float. Go ahead and change this one back there. Now moving on to the list. So list actually has multiple ways that you can go ahead and try and return the values here. So what we can do is we can either do a straight up list like that, or we can go ahead and say from typing import list. And then in this case, it would be def, let's go ahead and just copy this. And then so down here in this case, it would be an example number 3, and we would just say list like that. And typically whenever you are going to go through the effort of typing out what type of data type you want to go with, typically you want to go ahead and define what the data type is inside of the list. So in this case, you could have a list of int. That is exactly how that looks. So it's really cool. I think that it's super beneficial. I'm not sure if this works. Yeah, so this is actually like one of the drawbacks to having the other way. Like as you can see here, it can't be parameterized. And so this is like one of the major advantages of using the type hinting of the actual built-in library versus like trying to use the built-in data types themselves. Down here below, you can see that we're still able to convert that to string, no problem. Switching over here to the sets. So sets is also one of those ones that you can go ahead and import from typing itself. We're gonna go ahead and paste this down below. We have now example number 4. We are cruising along as long as I can type here. Example number 4 here, we have it defined as a set. And then in this set, we also want this to be an int, and everything is happy once again. There is nothing to stop you, again, from just doing a basic, I don't know, maybe the set data types can change. If that's the case, you might want to try the union, which we'll be covering here in 2 more. But yeah, let's go ahead and jump into the tuple. So for our next one down here, tuple is also one of those ones that can be imported from the typing module down below. So in this one, we are going to go ahead and paste, go to example 5, rinse and repeat at this point, right? Tuple, int, we're all good. And then the union is actually a fun one. So this is like one of my more, this is like one of those ones that I really am happy that they went through the effort to do some type of a typing module. So this is a case where you have a function defined as example 6, and then you're going to go ahead and say this is a union, and then you're going to say int and float. So what you're telling the IDE is that eng is going to be an input, and it could be one of the 2 types. It could either be int or it could be float. Now, if you wanted something to happen where you want it to be a list of unions, then you'd have to do something a little bit more different, where you have to say like list, and then the list would be defined as a union of either int and float. That just means that you could have a list of 1, 1.2, 3, whatever, and so forth. So moving on down here to the dictionary, I believe that dictionary also has one built in for it, and it does. Going down here, we're just going to do a nice little copy pasta down here to an example number 7, doing a dict, and similar to how we did everywhere else, we're going to go ahead and tell it what type we want here. So it's going to be a string to an int data type. That's just telling the IDE that, hey, I have a dictionary object. The key is going to be of string type, and the values are going to be of int. Down below, we have none. So there's multiple ways that you can go ahead and do this. I've seen some people go ahead and use the caret arrow. I don't really know what the right name for this is, so if you know it, go ahead and comment down below. But I've seen people that just do like the caret arrow and then they say none. I've also seen some people do no return, which I really kind of like, and I think I'm leaning towards that now. As long, like for the output, obviously, not for the input. You can't do no return for the input. It just doesn't make any sense. So from typing import no return, go ahead and paste, go into example number 8 here. We're going to go ahead and say no return, and now this should highlight. It should anyway. And so now we're able to define this function as a list input, and we are just going to do a no return straight up. Everything's all happy path here. Now in a similar example down here for example number 9, we have a eng of type none, and it's going to be returned as a string. And so this is like where you could get kind of creative. You know, you could have it be of none type there. You could have some value be passed in as a list and then returning none, where it would look something like, you know, like this. My fault. And then you could just do that. Everything's all happy. To each their own though. And then the optional one is probably the best typing import out there. So optional allows you to define a new function as 10. And then we are going to make this optional, and we're going to say string. So you're going to say something like this. This is really, really cool. So what optional is doing is it's saying that I'm either going to return a data type of string or it's going to be nothing at all. So this is really, really cool. And I think that it allows developers to semantically look at a function and say, oh, the output's optional. So therefore, I could either like define the attribute for this class now, or I could assign it later. If you ever worked with constructors and data classes, sometimes the default value for them is none. So the type hint for them would be an optional, whatever you're expecting that attribute to be assigned to at a later time. Switching over here to the subclass module. Subclass is super cool. So what subclass basically does is it creates a virtual shell into a terminal or a command line equivalent, and it allows you to run like shell script commands via Python code. I think that this is super helpful, and that's like a high level overview of what the subclass is doing. That's like a high level overview of what subprocess is doing. So switching up to the next question here, we have, when should I use subprocess versus writing a simple script? So this is a question that gets asked all of the time. I personally think that writing a simple script is super useful from the standpoint of if you want to like encapsulate the logic of the script in a function, then that totally makes sense. You can go ahead and do that. I think that you get more flexibility, however, with subprocess because subprocess itself is like a shell orchestrator. It can actually terminate PIDs. It can create new ones. It can pretty much do anything that a user can do from within the actual shell in their operating system. So I just personally like to default to subprocess whenever I can. However, that's not always the case. I know typically, like whenever you're trying to deploy something to a Docker instance or whatever, you have to write some type of a script to get that Docker instance up and running with the Python code that you need. So it is all dependent on what you're trying to achieve. I think that subprocess has a wider range of flexibility than a simple script does, but that's just me and my personal experience. And so jumping over here into our last question we have, is there an advantage to using subprocess over scripts? So like I said, it's all about flexibility. I think that you actually get to manage the actual shell instance if you use the subprocess module, where you just don't get that type of insight if you're running a top-down approach of a script. A script is very stupid in the sense of it does exactly what it's told and nothing more, nothing less, whereas the subprocess is essentially an instance or a clone of your actual shell. And you could kill off other PIDs, you could create new ones, you could spawn up like multiple types of threads in your machine. Like there's just so much more power with subprocess from a coding perspective that I think that you could do a lot more. I think that subprocess is probably like the defaulted behavior that I like to go down. But again, don't overcomplicate something if you don't have to. There's a lot that can be done with a simple shell script that you just don't really need to like continue to go down with like a subprocess. So let's go ahead and jump down here into our example portion. So similar to the typing module, this is a built-in library of Python. So if you want, you can go ahead and go open up your terminal or Python shell, whichever is your preference, and you can go ahead and say import subprocess. And now that you've gone ahead and imported the module subprocess, we can also define a command. So the command is whatever you want to run inside of your what's it called? So your command is whatever you want to actually run inside of your shell. So if you want to print out the PWD of whatever your path is, then you would write something, you know, like echo PWD, or and let's say that you had a specific exported variable that you wanted to go ahead and assign, then you could go ahead and do that. And even more, you could even go ahead and actually send off curl requests, which is kind of what we're getting at here. You could end up doing some type of a multi-threading, we'll cover that in a later video, where you could really hammer down on making someone's life a living hell. But let's go ahead and just like run a simple command here of like a, let's just do, so I think for our example here, we're just going to do a simple ls-l. It is just going to list out what is inside of our directory that we're currently sitting in at the time of running this. So for this first argument, it's actually going to be cmd equals cmd. Is that not right? Highlight over popen cls. Okay, so this is where you just say cmd, and then you have to do std. I want to say it's out equals subprocess dot pipe. Std error equals subprocess dot pipe. You could definitely go ahead and make a shortcut and say from subprocess import pipe, and then just put that right there. Is there something else I'm missing here? Yes, shell equals true. So that tells it like, hey, go ahead and spin up its own new shell for this. Don't take an existing one. I always default to having shell equals true. And then this is where we go ahead and run a pipe.communicate. What this does is it actually performs the call made in the popen command. It communicates it, and then it waits for an exit code response, whether it be a 0, 1, or something else. And then I go ahead and set this to, I want to say, so what I'm going to go ahead and do is I'm going to say out, comma, error equals this. Communicate will actually unpack all of the happy path into the out value, and then any type of error caught will be going ahead and being dumped into the error message. So now I can go ahead and just say print out. And so what this should return is a actual listing out of what my physical directory is where I'm running Python out of. Let's go ahead and see if this works. And as you can see down below here, I was able to print out my entire directory of where I currently am just by running this command here. All I'm doing is printing out, and then the out is all being dumped into a, well, it's basically being concatenated to everything with it being delimited by a new line character at the end of each line. There are some pretty ways to get that output, but I think as a high level overview, this is what I was trying to show off. The beauty behind using subprocess, and I think we're going to end up using it in a future video, but this was just meant to be like a general introductory to how subprocess works. I strongly encourage you to go down your own little wormhole and try and figure out what the nooks and crannies are of subprocess. But that's going to do it for today's video. As always, if you like today's content, feel free to like, comment, subscribe. Let me know what I missed out on, and let me know what you want to see in the future. But that's going to do it for this one. I'll catch you in the next one. See you.